If the derivative of y is this, how many relative minimum will the graph of y have? Here dy over dx is given already. So what we have to do is we have to do the first derivative test. Let's say this is number line x. Since all of this expression is factored already, we know that dy over dx is equal to 0 when x is equal to 1, or 2, or negative 1/2. These are critical points. So let me write negative 1/2 here, 1 here, 2 here. So in each of these intervals, dy over dx, or let's say y prime, if we plug in negative 1 for x, negative 1, negative 1, negative 1, this is x minus 1 squared, right? So this is always positive. Minus 1 minus 2, that's negative. Minus 2 plus 1, that's negative. So negative times negative, that's a positive. So positive here. If we plug in 0 for x, 0, 0, 0, this is always a positive. Minus 2 times plus 1, minus times a plus, that's negative. So negative here, substitute maybe 1.5, 1.5, 1.5, 1.5. This is a positive. 1.5 minus 2, that's negative. 3 plus 1, that's positive. So negative times a positive, that's a negative. Negative here. So lastly, plug in 3. 3, 3, 3. So positive times 3 minus 2, positive. 6 plus 1, positive. So they're all positive. So this interval must be positive. So y prime is positive, negative, negative, positive. Then we know that the graph of y increase, then decrease, 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 then increase. So how many relative minimum does the graph of y have? It only has one relative minimum, right? So the answer is 1.